BMW produced the first luxury sedan that is powered by a hydrogen internal combustion engine, and it's called the BMW Hydrogen 7. Sooner or later we know that we're going to run out of oil, so we have to come up with alternative fuels for the future, for future mobility, and hydrogen is, it doesn't produce any carbon, so you don't have any CO2 emissions. That's the first good thing, so you get rid of the greenhouse gases. The second, hydrogen can be produced using renewable clean technologies like solar, wind, geothermal. And last but not least, hydrogen can be produced in very stable areas of the globe, which is necessary for energy security. The BMW Hydrogen 7 uses liquid hydrogen at very, very low temperature, minus 418 degrees Fahrenheit, but also at very, very low pressure. So we're working with atmospheric pressure, 30 to 40 psi. We have done, the Hydrogen 7 is not a concept car anymore, it's a series developed car, so it's not a prototype anymore. We've done all the safety and crash tests with this car as with any other BMW, and we specifically heavily tested the safety of the hydrogen tank and the hydrogen as a fuel. So, and independent authorities confirm that hydrogen as a fuel, the safety level of hydrogen is comparable to that of gasoline. So it's really just a new type of fuel we have to get used to, but it's not more dangerous than working with gasoline, it's just different. BMW has been working on hydrogen technology or hydrogen internal combustion engines now for almost 30 years, so it's not just something that came around the corner recently. We have done some extensive testing already. This is the 6th generation of hydrogen-powered cars at BMW, but now it's really the first where we can actually hand over the keys to customers that can drive the vehicle on a regular basis. The challenge now really is the technology here is available today, and we can really show with the Hydrogen 7 that you can drive a very luxurious, safe, performing car, but yet being environmentally friendly. The challenge is where would you fill up with hydrogen? So the next step now would be, hopefully with this car, showing that the technology is available today will give an impulse to the industry that they start building up the hydrogen infrastructure. And also it will be necessary that the hydrogen we're going to be using will be produced in a quantity by economical methods. The BMW Hydrogen 7 has near zero emission. We do have some lubricant oils, so we do have little emissions, but they were so tiny that Argonne National Lab, who actually did some testing on our emission, was hardly able to measure those emissions. However, we didn't get so far the gold standard by the CEF mandate. We got a Silver Plus mandate with our vehicle. The gold standard is really zero emission vehicles, fuel cell vehicles, and battery electric vehicles where you have zero emission. With our car, since we do use an internal combustion engine and we do have some oils in the engine, we're not really zero emission, but actually Argonne found that the air that goes into the Hydrogen 7 and the air that comes out of the tailpipe, that the air that comes out of the tailpipe is actually cleaner than the air that goes in the internal combustion engine. So actually by using the Hydrogen 7, you're cleaning the air. And currently, for example, there's really one major corporation in Europe, it's called the Clean Energy Partnership, where manufacturers and energy companies and transportation services are working very, very closely together. Besides BMW, it's GM, Ford, Volkswagen, Linde, Total, and so they are really cooperating. We're really cooperating very closely together on making this happen. Really, currently the challenge is first to produce hydrogen in quantity by economic methods, and then second, get the infrastructure going. And for this, we need a lot of political involvement and a lot of economical efforts to make this happen. The car is here today. I can hand you the keys over and you can go for a ride and you can use the car every day. However, the obstacle really currently is, where would you fill up with hydrogen? And BMW is a car manufacturer, and we kind of overcome the chicken and egg problem already by showing that we as a manufacturer, we're ready, we're here, the car is here today. We now really hope that we give an impulse to the industry, especially to the energy companies and oil companies, that they start building up the hydrogen filling infrastructure. We're using liquid hydrogen, and a lot of our competitors, or in this field, our partners in getting to a hydrogen future, they're working with gaseous hydrogen for fuel cell vehicles. But this shouldn't be a problem, because usually also gaseous hydrogen is transported and stored in liquid form. So you can have a filling station where the tank is holding liquid hydrogen, is very, very low temperature and very low pressure, and you can have one dispenser for gaseous and one for liquid hydrogen. Again, I mean, the car is here, we're ready. We just now, in the next step, need the infrastructure to be built up. We're gonna need some regulations for hydrogen as a future fuel. So politics will be involved, businesses need to be involved to get the money for building up the infrastructure. So there are a lot of components where we as BMW are very uncertain of, so we can't really tell currently when we're gonna be able to sell those cars. Actually, with the Hydrogen 7, we had intensive training with fire departments. So we made the fire marshals aware that this car is now driving on California roads and also New Jersey roads. And we trained the fire marshals, we showed them what to do in case of an emergency with a hydrogen-powered vehicle. So we as a manufacturer, we try to cover as many aspects as possible to really get those streets out on the road and give the keys to regular customers. In order to get the cars out on the road, we are working very, very close with fire marshals here in California, but also in New Jersey, where we have cars on the road actually driven by regular customers, so that they really feel safe and comfortable driving hydrogen-powered vehicles. And they got all the training, they know what to do in case of an emergency, so they're very familiar with our product already. Currently, BMW owns 3 filling stations. We have 1 permanent here installed in Oxnard, and we got 2 mobile filling stations. These mobile filling stations actually help us showing off the technology all over the country, not just in 2 or 3 specific places. So we can actually move those filling stations around and fill up with hydrogen wherever needed to demonstrate the technology. But in future, again, we would need, when we would really want to sell those cars, we would need to have an infrastructure available without moving filling stations. We really need filling stations where the customer knows he can go to whenever he's running low on hydrogen. BMW's long-term strategy is really using a hydrogen-powered internal combustion engine, and the reason is, first of all, the internal combustion engine is a very well-known technology, and it's way cheaper than other solutions that are out now, so that we can really be able to offer something to the customer within the next couple of years that is feasible. Second, we decided to go with liquid hydrogen rather than compressed hydrogen, because in order to power such a big car as a 7 Series, in order to power such a performing and safe car, you need a lot of energy. And that's the only way you can get a lot of energy is by using liquid hydrogen. Safety level of hydrogen as a fuel is really comparable to that of gasoline. We have independent authorities to confirm this. It's just a different type of fuel we have to get used to working with, but it's as safe as driving a gasoline vehicle. It's just that you don't think about this anymore. When you pull up to a gasoline filling station, you fill up with gasoline. It's so normal to us now, and in future we're gonna have the same with hydrogen. It's really just a new type of fuel we have to get used to. The benefit of liquid hydrogen is really that it carries a lot of energy. And in order to power such a big car as the Hydrogen 7, you need a lot of energy. And that's why BMW decided to go with liquid hydrogen rather than compressed gaseous hydrogen. As you might know, the gaseous compressed hydrogen vehicles that are out there are fairly small compared to our Hydrogen 7. So BMW is a brand, sheer driving pleasure. You just want to keep those brand values, of course, performance, safety, luxury, and that's why we decided to go with liquid rather than compressed. The pros of liquid hydrogen is that we store it at very low temperature and very low pressure. We are using atmospheric pressure 30 to 40 psi, whereas compressed or gaseous hydrogen vehicles, they store the hydrogen at 5,000 to 10,000 psi. This is a disadvantage of the liquid hydrogen actually, is that over time the liquid becomes gaseous, so the pressure inside the tank rises, and we have to audibly release in a controlled manner some of the hydrogen so that we keep the pressure inside the tank at a level where it should be. So unfortunately that's one of the disadvantages currently working with liquid hydrogen, that over time we're going to lose some hydrogen, not pure hydrogen. There's catalytic converter that's in the car that actually releases the hydrogen in form of water vapor. But this is a technology that is evolving, developing all the time, constantly. So in future, this also will be something our engineers will be working on, and definitely will come up with nice solutions for the future. The disadvantage of gaseous hydrogen is really just that you need a lot of space, a lot of volume, if you want to power bigger cars, and plus they store the hydrogen at very, very high pressure, 5,000 to 10,000 psi, and I always prefer sitting on a low pressure tank than on a high pressure tank. Well, usually also gaseous hydrogen is transported in liquid form because that's just way more comfortable of transporting hydrogen. So this is, again, now we're back to a common base. Hydrogen will be transported in liquid form and will be probably stored also at a filling station in liquid form, and then you can have a gaseous dispenser and you can have a liquid dispenser, but we can all use the same tank of hydrogen. My name is Nadine Jambo. I'm working on the BMW Clean Energy program here in Oxnard, California. I'm standing in front of the BMW Hydrogen 7, which is the first luxury sedan in the world that is powered by a hydrogen internal combustion engine. Well, the BMW Hydrogen 7 uses a regular internal combustion engine, so a very well-known technology. We decided to use liquid rather than gaseous hydrogen because in order to power such a big car, you need a lot of energy, and we only get this energy out of liquid hydrogen rather than compressed or gaseous hydrogen. Plus hydrogen on its own, why is BMW using hydrogen? You do not produce any carbons, so there are no CO2 emissions when you burn hydrogen inside an internal combustion engine. And hydrogen can be produced from renewable energy sources like wind, solar, water, geothermal. And last but not least, you can produce hydrogen in very stable areas of the world. So basically, hydrogen is everywhere. There's an unlimited amount available. So this secures the energy supply. In terms of safety, we store hydrogen, as mentioned, in liquid form at very, very low temperature, minus 418 degrees Fahrenheit. And also at very, very low pressure. So we basically use atmospheric pressure, 30 to 40 psi, whereas compressed hydrogen is usually stored at 5,000 to 10,000 psi. BMW has been working on hydrogen internal combustion engines now for almost 30 years. This is the 6th generation of hydrogen-powered cars at BMW. So this car has been produced end of 2006, and we started this project here in the US beginning 2007. What we do is we produce 100 units worldwide. We got 20 of these here in the United States, and we use them at events. We demonstrate to politics, to entertainment people to people from business sector, that technology is available today to drive such a beautiful car, but yet being environmentally friendly. We actually got a couple of high visibility people here in the LA area, but also in New York City and Washington, that have been driving the car for some time, to give us their opinion on the technology and provide us with some feedback that we can integrate in further developments of this technology. Currently, unfortunately, we only got a couple of filling stations here in the United States and also in Europe. So this is really currently to demonstrate the technology. The car is available today, and hopefully give an impulse to the industry that they start building up the infrastructure. At this point, BMW has investigated in some filling stations. So we got one permanent here in Oxnard where we can refill the cars for our LA customers. In future, we are currently working closely with energy companies, oil companies, other car manufacturers to really solve this issue, because it's not just an issue BMW is confronted with, but all the other manufacturers that are working with hydrogen as a future fuel. So in future, hopefully through those cooperations, we're gonna see hydrogen filling stations popping up. We are working very closely with the organizations you've mentioned, with AQD. We've been part of this year's hydrogen tour within the Fuel Cell Partnership. So we're demonstrating the technology as any other manufacturer does currently. And again, hopefully all these efforts will show that the technology is here. We now need the infrastructure. So to answer your question, we really work closely with those organizations. We work closely with Shell. Actually, we got a Shell hydrogen filling station in Washington, but also with other companies. Linde is our specific provider of hydrogen, and our hydrogen filling station has been coming from Linde. I think there should be a legal framework, so we need to come up with some regulations for hydrogen as a future fuel. So government needs to be involved, of course, in the first step, and then the industry. It's a question of money, no doubt. So it will cost some money to install the infrastructure for hydrogen filling stations, so that you get a network comparable to that of gasoline filling stations. It will take political and also economical efforts to create this hydrogen infrastructure in future. We are ready. I mean, this is not a prototype anymore. This is a serious developed car. So as soon as the infrastructure is available, we'll definitely be able to mass produce those cars.